Hey guys, welcome back to my channel. So we're heading back to the land of insane creatures this week, and I recently read about this incredible discovery, or really just the tip of a potential discovery, in the Greenland shark. And this might not be a shark that you're familiar with. It doesn't get as much play as the great white or the hammerhead, but this shark is crazy, both in its size, growth, and longevity. But a recently published study is rethinking what scientists thought they knew about these sharks and how that information can help humans maintain our vision longer as we age, which I think is something that we are all collectively interested in. So settle in, get cozy, and let's go over the potential connection between shark eyes and human eyes. So as I mentioned, this insane shark that we are talking about is the Greenland shark, respectively known as Somniosus microcephalus. And this shark is well known for its impressive lifespan and is actually thought to be the longest living vertebrate. Now, the exact age of each shark varies, but it's thought that they live to be at least 250 years old, but as long as over 400 years old. And while I was researching this video, I found this headline about Greenland sharks that said, it's 7 meters long, can weigh almost a ton, and can live for 400 years or more, meaning some around today were born in 1625, which is completely true. So I'm like, wait, are there living Greenland sharks swimming around today that are older than the United States? I mean, maybe? But yes, they typically grow to be about 8 to 14 feet long, about 2.5 to 4.5 meters, but they can grow up to 24 feet long, which is nearly 7.5 meters. And they often weigh over 1,000 kilograms, or about 2,200 pounds. That is a lot of shark. But what's really interesting about all these factoids is how slow the Greenland shark grows. And because they live so long, they are not in a rush and only grow about 1/3 of an inch per year. And because they are late bloomers, to say the least, this shark doesn't reach sexual maturity until around 150 years old, and often live for at least a couple more centuries after that. All of this also means that these guys are not exactly in a rush to birth the next generation of Greenland sharks. Pups are only born after 8 to 18 years in gestation, after which they spend the rest of their lives swimming around the frigid North Atlantic and Arctic Ocean at depths as low as 3,900 feet. And as a woman, I gotta say, a decade or so of being pregnant? Wow. Just wow. But while all of this is very interesting, very standard, isn't nature miraculous, the real juicy tidbit here is the recent study on the eyes of these sharks and how new information on how their vision works as they age could help experts better treat debilitating ocular diseases in humans. According to new research recently published in the journal Nature Communications, the Greenland shark retained its visual organs throughout millions of years of evolution for a reason. Now, these sharks spend most of their time swimming around in the dark, which is why heightened vision isn't as big an issue in such a dim environment, which is why most deep-sea creatures are functionally blind. And for many decades, many scientists also assumed that this was the case for the Greenland shark. Although these sharks still feature baseball-sized eyeballs, they're opaque and often obscured by a small parasitic crustacean called a copod that attaches to the organs. But after reviewing some recent video footage of live specimens and examining some harvested eyes in a lab, biologists now think that there is more to see with the Greenland shark, so to speak. Physiologist and study co-author Dorota Skoronska-Krocek was studying some rare video footage of live Greenland sharks when she noticed something. She said, "You see it move its eye. The shark is tracking the light. It's fascinating." Skoronska-Krocek first became interested in the Greenland shark's vision around 6 years ago, after reading a study published in the journal Science. She said, "One of my takeaway conclusions was that many Greenland sharks have parasites attached to their eyes, which could impair their vision. Evolutionarily speaking, you don't keep the organ that you don't need. But after watching many videos, I realized this animal is moving its eyeball toward the light." After organizing an international team of researchers researchers, including University of Copenhagen marine biologists working off the coast of Greenland's Disco Island, scientists caught Greenland shark specimens during multiple expeditions between 2020 and 2024. They then dissected and preserved individual eyeballs before shipping them off to Skowronska-Krochek's lab. Study co-author Emily Tom said, "I opened the package and there was this giant 200-year-old eyeball sitting on dry ice, just staring back at me." After carefully thawing the eyes, Tom and her colleagues analyzed the organs. They noted typical deep-sea visual adaptations like the presence of densely packed, lengthier rods, or photoreceptors, designed to function better in lower light. However, they also found other unexpected features. The team wrote in their study, "We confirmed the presence of essential visual cell types, rods, Mueller glia, and bipolar, amacrine, and ganglion cells. Moreover, despite being over a century old, the examined specimens showed no obvious signs of retinal degeneration. They also observed that parasites on the cornea didn't hinder the light from reaching the shark's retina." Although early in her research, Skowronska-Krochek and her colleagues believe that the Greenland sharks have evolved a DNA repair mechanism to guard their vision over hundreds of years. They also believe that a better understanding of the complexities of shark eyes could lead to new treatments for age-related vision problems in humans. For example, discovering how a Greenland shark maintains its healthy ocular cells and tissues for centuries may help develop therapies for diseases including glaucoma and macular degeneration that often develop later in life. The information could also inform our wider understanding of vision evolution across the animal world. Emily Tom said, "Not a lot of people are working on sharks, especially shark vision. We can learn so much about vision and longevity from a long-lived species like the Greenland shark." Tom and her team are still searching for funding to continue their research, which she maintains is very important. But despite the uncertainties, Skowronska-Krochek said that, like the Greenland shark, it is important to see the bigger picture, and promised we will prevail. I'll attach their study from nature.com in the description below if you want to check it out. So what do you guys think? I mean, first of all, a shark that can live up to 400 years. I don't know why I'm doing this. Up to 400 years, incredible. But a shark that can live up to 400 years and still have working eyeballs? I mean, understanding the how and the why of that seems potentially enormously helpful for human beings. This reminds me of one of the things that I love about the research done on ISS. The research is meant for one purpose, but then the result can sometimes solve a completely different problem that was not the original intention. These accidental connections, I think, are always so amazing, and I'm so grateful that there are scientists out there spotting these things, because you never know where any discovery, no matter how small, can take you. Okay, that's it for now. Thank you so much for watching, guys, and as always, I will see you in the next video.